Yes. Hello. Harry Roberts has begun his talk. He used in his talk a picture of a space picture, and I'm going to use a space picture too because my mother was part of Russian space program, and I was brought up on a lot of stories about space exploration. And while preparing this talk, I remembered one of the stories. What do you think is the most difficult part of training for American astronauts? It's an exam in Russian. Russian language training is a mandatory requirement for all candidates for American space program. Why? In 2003, Shuttle Columbia crashed, and that ended American-owned space program. And since that time, the only way for people to get to orbit is Russian spacecraft Soyuz. Now, all controls in Russian spacecraft Soyuz are in Russian. But it would not be such a big deal to change them, to make them in two languages. It's easier than to make people learn the whole new language. So, why? According to the agreement, the captain of Soyuz is always a Russian. So it's always a Russian who is in charge when Soyuz is used. And Soyuz is used to deliver people to their orbit and take them back. These are the most difficult and the most dangerous parts of all space expeditions. And emergencies happen. And NASA realized that in case of emergency, the most efficient way for people to work on this emergency will be when captain and command center speak Russian. Yes, they do understand English, but it will be faster, it will be easier if they speak their own language. Because in emergency, it's not only seconds, it's split seconds that matter. There is no time for translation. There is no time for thinking how to phrase something in a foreign language. So the most efficient way will be if the captain and the command center speak their own language and the rest understand and is able to follow orders. For this only reason, months and months of training, very considerable human effort is spent just to make people achieve the most efficient way to work together. And this is what this lecture is about. Styleguide-driven development is the most efficient way for people with different origins, this time designers and developers, to work together by creating a design system as a shared language for both and by documenting this design system in a living front-end style guide and using this as a single source of truth for both. And we are going to talk, and this topic is a hype now, probably you've heard about this before. What we are going to do now is we are going to discuss the practical side of it. What it is, how it works, and most importantly, how to get there, how to start working this way. And we are going to cover this from both sides. That's why we're two on this stage. I'm a designer, I'm responsible for the design side, while Arvid, as a technical architect, he covers the developer's perspective.
Hi, my name is Arvid. I work as a technical architect. I assemble the teams and set the strategy how to develop the product. When we put designers and front-end developers together, we usually face issues how to organize this work. My experience is that the way you structure the design work also affects the way you develop the front-end architecture. Even the backend can be affected by this. What is wrong with the traditional process? What problems are we trying to solve? You receive a screen or a set of screens and begin with building it element by element. Take one element, pick its style in InVision, for instance. You use Bootstrap or some standard framework, tweak some parameters to make the appearance of the button fit the design. Then you take another element. Again, you style it. If you see similar elements, you will most likely copy the styling parameters to reuse them. But if you have seen the same text label 3 months ago, or even 3 screens ago, you most likely don't remember that you have already made this style. So you make it once again. and you end up having a lot of copies or with slight variations of the same element. At some point, the interface of GitHub had almost 2,500 unique hex codes. That makes interface really difficult to maintain, and the color is only one of the parameters. There's a lot of others. The second problem, if front-end implemented screen by screen, this can potentially lead to problems with the structure of both the front-end and the back-end. I have seen live examples of back-end code being more tied to the screens than to reusable services. Another problem. You need to reverse engineer the rules, how these elements are laid out in the interface. When you have to derive the rules from mockups, there is always room for interpretation, no matter how detailed the specification is. This header is 24 pixels from the input below. Is it the header that has 24 pixels padding, or the input, or do both have 12 pixels? We look at another mockup, and here is not an input, but a text right below the header, and the distance is 32 pixels. How did it happen? You need to analyze a lot of screens to reverse engineer each individual rule like this one. And when you receive another set of screens, and there are paddings not matching the rules, you have the right of the previous set, so you need to apply adjustments to your rules. This is the struggle people seldom hear about, because very often the developers just suffer in silence. So, working like this, we cannot reuse much of the elements we make. The design is messy, and the code base is difficult to maintain and hard to make changes, and redesign is really a pain. So how can we change this? Styleguide-driven development is building the interface not element by element, but as a system of reusable components. If the elements are standardized from the beginning, if they are put in the library and reused both by the designer and the front-end, you don't need to make them all over and have tons of variations. If the design of screens come along with the design system, if the rules how interfaces are built are made explicit, there is no need or less need for reverse engineering. Software developers have talked a long time about reusability and write once principle. This is often achieved by using patterns in programming, like object-oriented programming you have all heard about. The first time this was done was in 1967 by two Norwegians. They created the first object-oriented programming language called Simula67. This pattern is over 50 years old and still going strong. Object-oriented programming allowed the developer to define a set of properties and group the properties with operations. The developer could give properties and operations meaningful names, as well as hide internal data structure and business logic from the developers who only need to use these objects. Another well-known pattern is MVC, which describes how data are modeled, how they are viewed, and how access to its data are controlled. So, by learning and applying patterns, the developers get into well-known ways of how to structure the code. Patterns allow us to recognize the way code is crafted. Style-guide-driven development is also about patterns. It is applying patterns to the interface layout. It is creating the interface as a system of reusable components.
System of reusable components. What we are going to do now is describe how this system is constructed, and then talk about how to apply these principles in practice. So, as Arvid has mentioned, the system of components is basically a library of reusable components and explicit rules how we lay them out, how they work. And the important thing here is that it's not that designers create this system, give it to the developers, and then they work with it. It's both that create the system and it's both that use it. So creating the library. When we establish the library, we have to understand what elements we are going to put in it, what will be the reusable elements of the system. And we need to break the monolithic interface into reusable parts. How potentially this interface can be can be broken into into parts in many ways. How to break it into the parts that can be reused. The approach is surprisingly simple. What is an interface element in general? Interface element is a piece of functionality that enables us to accomplish an individual task. Now, the reusable element of a design system is something that enables us to accomplish repeatable tasks. Big tasks, small tasks, something that is done over and over again. So what we need to do is we need to find in our interface, in our flow of the user, things that the user needs to do over and over again. And find the tasks and find the elements that support these tasks. And the smallest elements are easiest to see. And this is a recruitment portal. And these guys are candidates on a Java developer position. And the repeatable thing that the user may need to do here is select one of these guys. And this select task is supported by a checkbox element. Another thing that we may need to do here repeatably is read names of these guys. And we have a repeatable element text label that supports this task. We may need to read through summary of these guys. And we have paragraphs here. We may need to see rating, and here are icons. All these tasks, select candidate, see the name, read summary, etc., are basic tasks. They cannot be broken any further into subtasks. And they're supported by basic elements, or the way we call them, atomic elements. So the first type of interface elements that we can see is the atomic elements that are the smallest standalone reusable pieces of the interface that enable the user accomplish the smallest standalone tasks. We can create these elements, put them in the library, and we'll be reusing them every time we need them. Good, but that is just the beginning. Very often, the smallest tasks that we do are parts of something bigger. And here, all this reading name, selecting, reading through summary is part of an evaluation of the candidate. And this evaluation is also a standalone task, only bigger than the basic ones. And this evaluation is similar for all candidates. Again, a standalone, repeatable task, only not as small as the basic ones, a complex task. And it's supported by a complex component, a card. And this complex element consists of smaller atomic elements that we have identified before. And using the same terminology, we call them molecular elements, or molecules. So molecular elements are complex elements of interface that consist of other elements, either just atomic elements, or they can also include in themselves other molecular elements. So they can differ in their complexity, like in real life. Water molecules is very simple, but also molecules can be as complex as DNA. So like in real life, the interface elements, complex interface elements can be relatively simple, like say a search box, or can be rather complex. But more or less complex, we can build them, put them in a library, and we will be reusing them. That will simplify the work, both for designers and developers. Now here, I often get a question. Why do you need to reinvent the wheel? There already are systems of reusable components. There already are frameworks that have their component library, that have well-defined rules. Why not use something like Bootstrap, Foundation, Material? And Google has made visual customization much easier in material design, so one more hurdle is away. Why not use this? Yes, visual customization has become easier and is getting more and more easier. But let's look not on the visual, but on the functional part of it. When we look at any interface, we see that atomic elements show up basically in almost any interface, and they are similar here. Like, again, in physics, oxygen is always oxygen in water and in DNA. The same way, button is always a button in a sports app, in a security app, or in this recruitment portal. It's the same. It may look slightly different, but it works the same way. It's constructed the same way. But when we come to more complex elements, they become more product specific. Here we see cards in a recipe manager, in an e-commerce website, and in a news app. And yes, they are also cards, like the ones I have shown in a recruitment portal, but they are different. They are displaying different content, and they enable different actions here. Why are they different? Why should they be different? Remember that, as I've said, the interface elements are closely connected to the tasks that these elements enable. And the tasks the user do here, even if it's evaluate an item task, will be different for a recipe manager or news app, because when you evaluate a recipe, you do different things than when you evaluate a news article. Therefore, the component that helps you to do this is different. And here we have looked at relatively simple components, cards, in relatively simple products. But if we go to something more complex, like oil drilling monitoring system, the components in these systems will be more difficult and will vary much more. And this approach, one size fits all, will be less and less suitable. So this is the main limitation why shortcuts like Bootstrap or Material doesn't work. I've come across a good citation here. Material design works well for Google because it was made by Google for Google. They were not made for you. If the tasks the user have to do in your interface are not the same or similar that the users do in Google, your material will always be a compromise, a functional compromise. So the best thing is to create a mini Bootstrap, mini Material for you, for your product, where the components are functionally optimized for the product. So the components needs to be defined for your products. When we have defined the elements, we need to understand how they're going to look and behave. And the most straightforward answer to the question how the elements of the interface should look, the way the designers have designed them to look, right? Well, and developers can build anything, however complex, however difficult it is, right? Professionals can do everything. Yes, they can. The question is if they should do this. Because no matter how developers think about implementation of custom, of complex components, it's always additional development time. And additional development time is additional development cost, and we have to consider that. And it's also implementation of custom elements is always an increased probability of issues, sometimes reduced performance. Developers know that. But by default, neither I nor the product team do. So how do we, without asking developers, decide whether to put this element in the library, how these elements are going to look and behave? Because it looks cool and because it's user-friendly. But we need to put understanding of the complexity into this formula. Yes, sometimes we will have to go for very custom, very difficult to build components, but we have to do this with our eyes open. It has to be an informed decision. So the decision how the elements should look and behave should not be a responsibility and the right for both the designers and developers. Another thing we have to agree on is such a simple thing as names. Calling things by the same name will simplify the communication, and it will also make us understand how the elements of this type are structured and what is the hierarchy of these elements is. For example, here, a button. Button, primary, basic, small. But primary, the use. We have to define different types of the use. Basic, the state. We have to understand what are the possible states of the elements that we use. Basic, who were small, who were pressed, etc. Small, the size. We have to understand what sizes of this element can be. And understanding, agreeing on the naming conventions here forces us to go through all these things and get to the shared understanding on these questions. The last thing we have to understand is what properties define these elements, which properties the front end need to build this element, and what measurement system we are using, what units we are using, and how we measure them. And also how they change with the change of the content or the change of the viewport. If the button gets a bigger label, how does it change? And if the viewport changes, how is the responsive behavior of the elements? We have to make these rules explicit and not to make developers reverse engineer them. Yes, establishing the library is work for the two of us, but that's just part of the work. We need to use this library together. How developers use this library, Arvid will tell. I'm talking about the designer side. I need to be able to use the same library as front ends. How do I do this? When I was looking for the answer to this question, some time ago, the only one I found was designers should work in browser. And it's still a very popular answer to this question. But this is a dead end. Now you may think, here's another one who is afraid of coding. I'm not afraid of coding as such. I have some IT background. I'm afraid of designing by code. Designing by code is designing by describing what you want to achieve. And it's the total opposite to designing by doing, designing by direct manipulation. Designing by direct manipulation is the way all visual creative work has been done since the beginning of times. A prehistoric man takes a stone and applies it to a wall, and here's the wall change the color, and he draws this wool. And he sees the wall change the color exactly where the stone is applied. A child takes a pencil and starts coloring this thing, and he sees the paper change the color where he applies the pencil and exactly when he applies the pencil. It's direct manipulation. And this is how creative work is done, and this is how creative work is done in our graphical software. We are moving, resizing elements, and see the difference, the changes as we are doing this. While designing by code is as if you blindfold the artist and make them describe what they want to achieve. Then open the eyes, see the result, and then make corrections. It's a funny experiment. You can draw a smiley face like this. But it's a bit difficult to draw a Mona Lisa like this. Now, they need to see how the strokes lay in order to draw something like this. I do not say that we draw Mona Lisas every time, but every time we need to do something more creative, something visually different from a well-defined standard view or variation of a well-defined view, we need to directly manipulate with our tools. So, designing in browser is not a solution. The solution we have found was to create a totally synchronized libraries in front end and our graphical software. Sketch and Adobe allows it, and yes, they consist of the same elements, but the thing is that they have to be constructed the same way. The inheritance of properties, the structure have to be the same or as similar as possible on the front end and on the design. They have to be one-to-one synchronized in the aspects that matter. So the biggest change in the work is the workflow for the designers. To achieve this working with the same library as the front end, I have to be drawing only with the library elements. And if I need something new, I create this new thing in the library using the atomic elements and then send over both the new mockup and the new element. So summarizing, going towards style guide-driven development means that for designers, it's a huge change in their workflow. They need to communicate with the developers, include them in the initial discussion, and they have to change the way they are actually drawing. What it means for the developer side, Arvid will cover.
Yes, now we're going to talk about implementing a library. First, we're going to look at components, and The component is a construct to keep together relevant information about how to render a view, its data, its operations, including how it's styled. So the basic principle about the component I will show you in a very simple example from Angular. Here is a component, very simple one. Here's the template section which defines its view, how it's rendered. It can also have interactions here. In these examples, there are no interactions, just showing some text. Simple styling is also applied here, but in this case, it's just very basic HTML tags. The useful part for the user is here, and the properties from the data object is here. And here is the link between them. In real life, this is what might be in the template section, and showing this is this part. And here is some parts of the code which is used in this component. Here is how to increment and decrement the value. To summarize, this is why component pattern is useful. Styling, view definition, properties, and logics for basic or complex elements are kept in a separate and easy to maintain part of the code. Then you might ask, can I use component in my platform? Yes, of course. It might be supported directly like Angular or Ember, while other frameworks might require some plumbing. But still the pattern can be applied regardless. How do we transfer the styles into real code? Here is a design system which we have received from a designer. And well, we can look at this. We have colors, text, etc. And then here is our folder structure that we use in our applications. You will see a fraction of our design system in code. This file is just a place where you load everything else. These folders, elements, are the smallest useful interface components like buttons and labels, and Tatiana talked about them and called them atoms. One of the basic elements here is that button. The text of the button is not part of the element definition, since every button can have different text, but they can have the same looks. And then we have bundles, molecules, a combination of basic and or other bundles. And here is a bundle, the custom value stepper for gift cards. It is a complex element. It consists of this input box and two buttons, one on each side for the stepping. But we can also reuse this for a quantity stepper, more or less. The root folder is a folder where we put global definitions. We define parameters once, and then we let all other elements inherit these definitions. The hierarchy of parameters should be close to the same as in the design system. Here we put color definitions, typography definitions, paddings, margins, other layout parameters, grid systems, which all elements and bundles implicitly inherit and utilize. Now I'm going to show you how we link the design system to the code. So here we see the color section. We define the colors only once in this table, and it's basically the same way as to structure other parts of object-oriented code using the inheritance, not to hard code the values more than once. Here it's easy to cheat and copy the hex codes all over, and then you get into trouble. Now I'm going to let's follow the primary color the way through the code. So here we define the link color should be the primary color. So now the link color inherits this property. And here is how we use the link color in the CSS or in the A tag. That means that all the links will use this color unless explicitly overridden. And this can apply also for buttons and labels and all other. We define only known colors. We can easily go back here if you want to change the primary color. Probably want to change the whole color set if we do, but let's assume that we only change this one. Now the whole interface in one go will change on the primary color. Then we can have a look at the typography section. Here we have names of the different fonts we use. Here we have them defined in a separate typography folder in the root folder. Here is some of our font definitions, and if you look closely, we use the golden ratio here to calculate the font parameters. The main point here is that we use the same names from the design system as we do in the code. And we also use here parameters to easily change how the fonts can be rescaled if we need to change them. And yeah, here's how we follow the font size all the way down into the CSS. So you get the font size, and then it goes into the H5. And here is a component that uses H5, and then the H5 is then used in this part of this view. So we basically use define things once and take them all the way to the interface. This is how we implement styling in our libraries. We can take our library even further. We can make separate screens or views that shows elements in a preview. It can be a set of simple pages for internal use, like here. Or it can be a nice and shiny style guide that you publish online. This is from MailChimp. And this style guide is live, so all elements here are the ones that are used in the product directly. Let's summarize the advantages of STD. First advantage, you automatically follow the rules. The rules are automatically applied to new elements when they are created. If you need to use overrides, it will be an intentional action. So this makes it harder to make mistakes like accidentally making a button with wrong size, with slightly different color, etc. And when we are doing redesign, we use the rules so that we can change the interface in a more smooth way. And we also improve quality because there is less need to verify design mistakes. Everything is consistent because everything is mathematically correct. When working the old way, when you derive the UI from a mock-up, you have much more freedom to break it down to elements and understand the sizing and positions. And mistakes will happen. Here they are more or less eliminated, or at least heavily reduced. So quite a lot of advantages for the developers. As Sally mentioned, our main jobs, we run a development company that builds different products for IT clients, products from different industries. They differ in scale, small ones and big ones, and they also differ in the stage when they arrive to us. Some projects we start from scratch, some we overtake from other developers. And in the last part of this lecture, we're going to talk about the key points we pay attention to when we start SDD in projects at different stages, new ones and old ones. We will start with new projects and we will look at the design side first.
building a design system for new products, we begin at the wireframe stage. And we start with atomic elements. As we have discussed before, atomic elements are showing up in any interface. And already on the level of the pencil sketches or more refined wireframes, we can see them. Here is a button, here are some icons. So basically what we need is to define here which of the elements we want, which buttons, which icons, and how many variations we want for the beginning. Here we already need to discuss naming conventions, measurement system, and the limitations that the framework can have on the appearance and the behavior of the elements. When we come to more complex elements, we approach them differently. We do not just ask which cards we need in our interface. We may not need cards at all. We may need something else. We again start with the user flow, and we look at the scenarios of the use. We see the flows that the interface has to support and how these flows are broken into the tasks. And we see where, in different parts of the interface, the same task is performed. And we see what content the user needs to manipulate with in these different parts of the interface with doing the same task. And from this, the goals of the user in this part of the flow and from the needs of the content, we construct the complex elements. What we do here is for all types of interface elements, we go back and forth quite a lot. So we do not just look at build the mockups and then chop them down and create a library. And we do not create a library first and then make interface out of these elements. We go back and forth quite a lot. Now we are on the buttons level, on the library level. Then we go back to the interface level and see how everything works on the mockup. Then we go back to the library, etc., etc. And every now and then we sit together with developers again and discuss the things that I have gone through before to make sure that everything is consistent and everything is considered and that all decisions that needs to be made together are made together. And the rest is very close to the theory, as I've described before, when it comes to the new products. Now the implementation of it.
New products development side. Initially, we don't have a library in place. In fact, we don't have code at all. So we have to start creating a library when you start coding. We follow two principles here. Do not make the mistakes of creating all types of elements you can derive from the design system before you actually need them. We usually start with building a basic structure for it, and then we make element by element as we need them for implementation. Do not spend 6 months creating a library and forget about the product itself. Second principle, build value early. So implement elements in views and then put them in the library if you need them once more, or if it's very clear that you are going to reuse them. So what to keep in mind? You cannot code the system before experimenting a bit, so make structure only after experimenting. Do not build new stuff as components straight if it's not obviously constructed for reusability. And remember to work agile also on the code structure. Do not create all possible variations of the components in code, like having different button states you don't yet need, etc. Yes, you might need a special variant someday, but that is someday. Remember, you have a system that allows to implement this later without too much fuss, if you do it like this. And then build components as you go. Yes, it's tempting to construct new ones, seen in mockups, but leave it until needed. The product might change until you reach this component anyway. Remember to make variables out of the styles so that you can have them easily maintained later, like we have done with this typography definition and the golden ratio.
it was quite easy for new products. When we have old products, things become more interesting. We have an existing interface to deal with, and we have to make sense of what we have. So what we need is to derive system from the existing screens or pages of the interface, and we will also most likely need to correct and minimize the system that is there. And how we correct and minimize the system, I will explain on a non-IT example. I have a son, and like many kids of his age, he plays a lot with Lego. And here are the cars that recently stood on his bedside table. And when you look at the cars like this, it's very difficult to see which elements that they are built from, and if there are, how many of them there are, how well they are reused, etc. You need to disassemble them in order to see the system, to have the overview of what you have. Luckily, my kid was curious enough to count how many bricks he used, so we did disassemble the cars, and then we left on the table one instance of each brick or wheel or whatever element here. And here we have counted 212 different elements in these 3 cars. And we do the same with the interface, only we do screenshotting. This is called interface audit. We screenshot all the views of the interface, or as many as is possible, and leave one instance of each UI pattern, put it in a PowerPoint, sketch, or some other document. And here's the fragment of such interface audit for a security app. And this is a very small app with a very few screens. And we have quite good overview here. And what we see is here we have too many buttons for a small app. So this is where we need some systemizing. How we do this? We look and see if 2 or more similar elements can be substituted with one. If we can reduce the quantity and increase the reusability here. And we did the same with Lego. 123 elements was left as a result. Poor kid, so few toys to play with. No, because from these 123 elements, he can build the same cars, only they will look more consistent with each other. And also, he can build these cars, and these cars, and these cars from the same 123 elements. So he can build quite a wide range of variations from these elements. And our goal is the same, to arrive to a minimum set of elements that will give enough flexibility in the interface. So from these buttons to arrive to these buttons on the atomic level. And on the molecular levels are systemized quite the same, but only we analyze the tasks the users do, and it may happen that the components eventually are very different from each other, doing the same task. So that eventually we change the way interface is laid out in some parts of it. And the goal of this systematization is to understand what we want to achieve on the design side for the product. But it's important, we want to achieve this, but how we develop it, depends a lot on the technical side.
Yes, old product development side. Make changes step by step. When you start working with a personal security app that Tatiana mentioned, the first thing the PO asked for was changes to the onboarding flow. So the designer drew the onboarding screens using library elements, button and input fields, text labels, and top navigation. And frontend also build these elements in library and use them on these screens. This way, we start standardizing and the UI starts to evolve. When the next part of the UI is about to be changed, then we have more tools in the toolbox or in this library. We already have some elements that we can use, the buttons and the inputs. And we create components of the new elements that we see here on this screen. The first time you are implementing an element with a new design, you'll find many parameters. Put them in the global section, primary color, secondary color, typography, and more. Do not rebuild unless necessary. A lot of developers have a tendency to say, I want to refactor everything, this is all code. But all products basically have some legacy. But by rebuilding the whole application, you gain nothing about the product for many weeks, months, even years in some cases. So to summarize all that we have talked about today, let's say if you want to go from point A to B, then you might need a car. In Norway, electric cars can drive in taxi and bus lanes. So you get from point A to B faster. And they can park cheaper, and the fuel cost is also much lower. And it's a more sustainable model from a global perspective. Yes, you can also buy a traditional diesel or gasoline car, and it will serve the purpose, take you from point A to B, but it doesn't have the advantages of the electric car that I have just named. So the advantages of Styleguide-driven development are the same. It's faster, cheaper, and more sustainable. Thank you very much. I can use this one.
I guess we are close to out of time, right?
Thanks. One question? Okay, so my favorite question was, how do style guides fit with agile development? So if you're iterating fast, is the design required before coding the app, or is it easy to adapt as you go along?
Yes, it's a small hurdle to overcome, but we try to do this very agile. We want to work agile even when we rebuild. So now we have a history of several mobile applications and several websites where we have done this very agile so that we don't break the product when we are restyling it. So first we restyle, and then we can actually rebuild the whole structure later.
As Arvid has said, we first touch the parts that we are rebuilding, and that is one thing, and we are touching only what we need to work on, so that is a small chunk of work. And also we are trying to do this the way that the rest of the interface will be affected as little as possible. There are design tricks for it, but we don't have time to explain all the tricks here, but there is a way to make this interface element so that the rest doesn't suffer, and you can do this in very small chunks. Out of time?
Yeah. Cool, thank you so much. If they want more answers to their questions, can they follow you on Twitter? How do we follow you on Twitter? Oh, you're up there, great. Cool, okay, thank you. Please give a big round of applause to Arvid and Tatiana.